Hello and welcome to Cliff Problem Part D. Again, we're referring to this problem, which you can find in the same directory as these videos in theproblem.txt. And what we're going to be doing is, what is the velocity and position of the ball at an elevation of 10 meters from the ground? Now, to do this, we're going to have to use some of the values from the previous problem there. Okay. So in this problem, we still have this cliff. It's 21 meters tall, and we're talking about a distance of 10 meters from the ground, right? Which of course means that we've come down 11 meters. Alright, so when we set up our table, horizontal, vertical, things we know for sure, well, it's still Earth, so it's still accelerating down 9.81 meters per second squared, and this is still 0. There's no horizontal acceleration. And we know that the vertical initial velocity is 0 because it's projected sideways like that. We don't know the final, right? So we know we're going to have to find that out, right? We do know this one, though, from the previous problem, that this is 8.216. And this is 8.216 because it can't change. The velocity started out that. It doesn't change because we're going to neglect air friction. Okay, and the other thing we know is that vertically we are down 11 meters. Okay, so what we need to really do is figure out this guy, and then we'll have across and over velocity, and we need to figure out this one here. And then we'll have how far down and how far over it is. Okay, so let's, I think the thing to do here is to find this guy first, because we know this, this, and this, right? It seems to me that we ought to be able to use no v, huh? Equals ut plus 1/2 at squared, right? And we want to find t, and this is easy. Okay, yes, this is easy. Okay. So we just solve for that. The initial velocity is 0, and so t is equal to the square root of twice s over a. Right, so it looks like the square root of twice negative 11 divided by negative 9.81, which in our calculator looks like this. And there it is. And we can hit enter. And it takes 1.498 seconds, we'll just say. 498 seconds, and that's the same time goes across, 1.48 seconds. Okay. And then we can also find our final velocity here. Okay. For that one, I would choose to use v squared equals u squared plus 2as. Okay, and v equals the square root of 0 squared plus 2 times negative 9.81 times negative 11, like that. And in our calculator that looks like this. Oh, look at that. Oh. Let's try that again here. On our calculator it looks like this. 14.69. Okay, but that is of course the absolute value of v equals 14.69. Okay, we know that the real velocity here is negative 14.69. That is, we're sure that the thing is going down. Okay, and then if we want to figure out this thing here, all it is s equals u t plus, well, 1/2 at squared. There's no acceleration, so there's no 1/2 at squared. So s just equals ut. That equals 8.216 and we got that from the other part of the problem, part A. Okay, and then this is 1.498. Okay, and we can do that in the calculator. 8.216 times 498. Okay, and that's 12.3 meters. Yeah? And now we know everything. Okay? We know, we wanted to know the velocity and position. We now know the position. That we are out here 12.3 meters. Okay, we are moving over at this instant in time. We're moving over 8.216 meters per second and down 14.69 meters per second, and so the velocity right here, we could find the angle that this makes, and we could find the hypotenuse there. So there's our expression for the angle is inverse tangent of 14.69 over 8.216, which in the calculator looks like this. 60.78 degrees. Okay, so this angle here is inverse tangent of the opposite side over the adjacent side, right? Opposite over adjacent, 60.78 degrees. It looks like it could be that angle, right? 61 degrees. Okay, and then the hypotenuse is the square root of 8.216 squared plus 1469 squared. Be very careful of putting the minus signs in there. It's the same hypotenuse, but your TI calculator might not get it right. In your calculator, it looks like this. 16.83. Okay. And if we only have 2 sig figs, we would have to say that this is about 17 meters per second, 61 degrees below horizontal, like that. And that is our velocity. Our position is 11 down, 12.3 over. And that's that.